7007. What procedure should be used to correct for slight ballooning during landing? A. Decrease power. B. Decrease angle of attack. C. Hold a constant landing attitude. The correct answer is C. Ballooning during landing refers to a situation where the aircraft temporarily gains altitude or experiences a sudden increase in lift just before touchdown. It can occur due to factors such as misjudging the rate of sink or a sudden gust of wind. When faced with slight ballooning, it is important for the pilot to maintain a constant landing attitude. The landing attitude refers to the pitch attitude or the angle at which the aircraft's nose is positioned relative to the horizon during the landing phase. By holding a constant landing attitude, the pilot keeps the aircraft in a stable configuration and avoids making abrupt control inputs that could exacerbate the ballooning effect. This means that the pilot should avoid abruptly reducing power or decreasing the angle of attack. Instead, the pilot should maintain a consistent pitch attitude that is appropriate for landing. This typically involves keeping the aircraft's nose slightly raised just above the horizon to gradually reduce the descent rate and initiate the flare for a smooth touchdown. By holding a constant landing attitude, the pilot allows the excess energy to dissipate gradually, reducing the ballooning effect and facilitating a smoother landing. It provides better control over the aircraft and minimizes the risk of a hard touchdown or a bounce. 7009. When beginning a rectangular course, the determining factor in deciding the distance from the field boundary at which an aircraft should be flown is the A. Wind speed. B. Size of the rectangular area chosen. C. Steepness of the bank desired in the turns. The correct answer is C. A rectangular course is a maneuver where an aircraft flies a series of 490-degree turns, forming a rectangle, while maintaining a constant altitude. The question asks about the determining factor in deciding the distance from the field boundary at which the aircraft should be flown when starting the rectangular course. The steepness of the bank desired in the turns is the key factor in making this decision. The bank refers to the angle at which the wings of the aircraft are inclined to the horizon during a turn. By adjusting the bank angle, a pilot can control the rate of turn and the radius of the turn. When starting a rectangular course, the pilot needs to consider the steepness of the bank desired in the turns to ensure that the aircraft remains within a safe distance from the field boundary. If the desired bank angle is steep, it will result in a tighter turn radius and a smaller turning area. In such a case, the aircraft should be flown at a greater distance from the field boundary to maintain a safe margin. Conversely, if the desired bank angle is shallow, it will result in a wider turn radius and a larger turning area. In this scenario, the aircraft can be flown at a relatively closer distance from the field boundary. 7024. In properly coordinated eights-on-pylons, if the reference point is behind the pylon, it means the A. Angle of bank is too shallow. B. Airplane is above the pivotal altitude. C. Airplane is below the pivotal altitude. The correct answer is B. Eights-on-pylons is a maneuver where an aircraft performs coordinated figure-eight patterns around two pylons located on the ground. The question states that the reference point is behind the pylon, and we need to determine the meaning of this scenario. During the maneuver, the pivotal altitude plays a crucial role. The pivotal altitude is the altitude at which the aircraft's ground speed is minimum while maintaining a constant radius turn around the pylon. It is the altitude where the aircraft achieves the most efficient turn. When the reference point is behind the pylon, it means that the aircraft is flying a higher path compared to the desired pivotal altitude. In other words, the aircraft is above the pivotal altitude. Being above the pivotal altitude has specific implications for the maneuver. It typically results in a larger turn radius and a faster ground speed than intended. The increased ground speed leads to the reference point appearing behind the pylon from the pilot's perspective. To correct this situation and bring the reference point back in front of the pylon, the pilot needs to reduce the aircraft's altitude. Descending to the pivotal altitude ensures that the aircraft achieves the desired ground speed and turn radius for a properly coordinated 8-on-pylons maneuver. 7024-1. What is the primary control during 8s-on-pylons? A. Aileron. B. Rudder. C. Elevator. The correct answer is C. 8s-on-pylons is a maneuver where an aircraft performs coordinated figure-8 patterns around two pylons located on the ground. The question asks about the primary control used during this maneuver. In 8s-on-pylons, the primary control used to maintain the desired flight path and altitude is the elevator. The elevator controls the pitch of the aircraft, which determines its climb or descent. During the maneuver, the pilot adjusts the elevator to maintain a constant altitude and to control the aircraft's pitch attitude as it transitions from one turn to the other. The elevator input helps in maintaining a consistent flight path and ensuring that the aircraft stays at the desired pivotal altitude. By properly using the elevator, the pilot can control the aircraft's climb or descent, allowing for smooth and coordinated turns around the pylons. Adjustments to the elevator are necessary to maintain the desired altitude, prevent altitude deviations, and ensure that the aircraft remains in the proper flight envelope throughout the maneuver. While the ailerons and rudder also play a role in maintaining coordination during 8s-on-pylons, the primary control for maintaining altitude and flight path is the elevator. 7025. The pivotal altitude for 8s-on-pylons is dependent primarily upon the A. Ground speed. B. True airspeed. C. Distance from the pylon. The correct answer is A. In 8s-on-pylons, the pivotal altitude is the altitude at which the aircraft's ground speed is minimum while maintaining a constant radius turn around the pylon. It is the altitude where the aircraft achieves the most efficient turn. The ground speed of the aircraft is the primary factor that determines the pivotal altitude. Ground speed refers to the actual speed at which the aircraft is moving relative to the ground. It takes into account the aircraft's true airspeed and the effects of wind. When the aircraft is flying at the pivotal altitude, the ground speed is minimized. This means that the aircraft is moving at its slowest speed relative to the ground while still maintaining a constant radius turn around the pylon. To find the pivotal altitude, the pilot must adjust the aircraft's altitude during the maneuver, taking into account the effect of wind on the ground speed. By observing the ground speed and making appropriate altitude adjustments, the pilot can determine the altitude at which the ground speed is minimized and achieve the desired pivotal altitude. While true airspeed and the distance from the pylon play a role in the maneuver, they are not the primary factors determining the pivotal altitude. The true airspeed is the speed of the aircraft through the air, and it influences the ground speed when combined with the effect of wind. The distance from the pylon affects the turn radius, but does not directly determine the pivotal altitude.